soft drinks, diet drinks, these are things which are routinely consumed. Perhaps you could talk about the relationship between these drinks and our wider health.
Right. So first of all, it's now been shown 50 ways from Sunday that sweetened beverages, sugar-sweetened beverages, soft drinks, are disastrous. They're disastrous for adults. They're disastrous for kids. Okay. And we have quantitation on just how many deaths per year occur in both the US and the UK due to soft drinks alone. This has been done by numerous investigators, most notably the ones at Tufts Friedman, like Dariush Mozafferi and his group, Renata Mika, et cetera. No question. So then you say, okay, that's true, but what about diet drinks? They have no fructose. They have no calories. They should work. They should be fine, right? Not so much. So here's why. A couple of studies have now shown exactly why. A couple of years ago, I wouldn't have been able to tell you this, but now we have the data that explains why this is. All right. Number one, you put something sweet on the tongue. Message goes tongue to brain, sugar's coming. Message goes brain to pancreas. Sugar's coming, release the insulin. But then the sugar never comes because it was a diet sweetener. What does the pancreas do? Does it say, oh man, I was waiting for that, I'll just wait till tomorrow? Or does it go, I got all these insulin vesicles sitting here, raring to go. Okay, I'm going to go find me some calories to work on.
Yeah.
And you end up overeating. Turns out it's the latter. We now have the data to show it's the latter. So, in fact, all the studies of diet drinks show that caloric intake, total caloric intake, does not change. So you think you're doing well by taking 150 calories in sugar out of your diet, but it turns out you end up making up those 150 calories elsewhere in your diet. It's been shown in different experimental conditions that basically it sensitizes your pancreas to actually make more insulin, those diet drinks. This was work from Yanina Pepino when she worked with Sam Klein at WashU St. Louis, and also Tay et al. That showed that if you consume diet sweeteners, okay, instead of sucrose, you will not consume as many calories in the morning because of the diet soda that you drank in the morning, but you will actually increase your food intake later on in the afternoon and evening, so that the total number of calories you ate ends up being exactly the same, which is why diet drinks have not caused anybody to lose weight, because you end up making it up later. That's number one. Number two, we now know that certain diet sweeteners actually alter the microbiome in a negative fashion and contribute to leaky gut, the most famous of which is sucralose, or Splenda. And worse yet, we now know that adipocytes, fat cells, have receptors for diet sweeteners. And so if you absorb those diet sweeteners, they go through your bloodstream, end up at your fat cell. They can cause fat deposition in the fat, irrespective of insulin. So the bottom line is diet sweeteners might trick your tongue, but they don't trick your body.
Yeah, and it kind of sort of makes sense, doesn't it? If we go back to the fact that, our biology, we've been wired over hundreds of thousands of years to, respond a certain way to certain things in our environment. We've just changed that so much. And did artificial sweeteners exist 100 years ago, 150 years ago? Has our biology learned how to adapt? Of course, it doesn't mean we can't learn, but I know it's a very controversial area, but my advice with my patients has always been, look, I'd be really cautious with this. I don't think you should go to that. I think I'd much prefer water or, something else, but I've always taken that more precautionary principle. I know many people vocal on social media will say that there's no problem with artificial sweeteners, but you think it's pretty clear now with artificial sweeteners?
Yeah, I think the data are in. There was a paper that came out in the American Journal of Clinical Nutrition about 2017. And what they did was they showed, we're using a meta-analysis, that the toxicity of one Coca-Cola equals the toxicity of 2 diet Coca-Colas.
Wow.
So half as bad. That doesn't mean good. That means half as bad. Now, the problem is, okay, it's half as bad, but people who are drinking diet soda say, oh, no fructose, no calories, I'll drink 5 of them.
Yeah.
Now it's 2.5 times as bad.
We've mentioned sugar as a mitochondrial poison. We've mentioned insulin resistance as a root cause of many of these chronic diseases. And we mentioned obesity and weight gain as a symptom rather than the cause.
Right.
One that we haven't quite mentioned yet is thin people who think they're okay because they don't look overweight, yet on the inside, there's a very different story. And I wonder if I could just frame that around the statistic, which I've heard before, you've written about it in your book, that 88% of Americans have a degree of metabolic dysfunction. But I also love the way that you describe metabolic syndrome. Maybe you could describe how you say it, because I think it's a beautifully simplistic way of looking at it, and then put it in the context of that thin person who thinks they're doing okay.
So here's the problem. Everybody thinks that the scale tells the truth. The scale tells you how much you weigh. Who cares? Seriously, who cares? And here's why the scale lies. Because there's not one fat depot. There are 3. 3 separate fat depots. And they contribute differentially to your health. Here they are. First one, the one you can see, the subcutaneous fat, the big butt fat, as it were. As in, do these genes make me look fat? I never answer that question. Yeah, bad idea. All right. Turns out the subcutaneous fat, while potentially cosmetically undesirable, is metabolically inert. Our subcutaneous fat is there very specifically to store energy for periods of famine, right? And it has an innate expansive capacity to a certain point before it gets into trouble. In fact, you can basically put on about 10 kilos of subcutaneous fat, about 22 pounds of subcutaneous fat, before you will have overexpanded those cells. Those cells will then have choked off and died, will have released their grease into the area, will have recruited macrophages in to clean up the grease, and will then have released cytokines into the bloodstream, which will, by the way, go into the systemic circulation. So you have to have a lot of grease in order to get a concentration high enough to go back to the liver to activate the cytokine response in the liver and cause insulin resistance. So 10 kilos of subcutaneous fat before you get sick. That's depot number 1. Depot number 2, the visceral fat, the belly fat. Okay, the beer belly, if you will, fat. Right? Now that fat turns out not to be from beer. That fat turns out to be from stress. From stress. You know a lot about stress. That fat in your belly fat, okay, visceral fat, is due to cortisol. And cortisol is because our world is now overly stressful, and people are overly stressed like all the time. So how do we know that? And the answer is because we can take patients with clinical depression, endogenous clinical depression, suicidal depression, get admitted to the hospital to keep them from themselves, put them in a scanner, and quantitate the amount of visceral fat. Now, they're losing weight because they're not eating. They're losing sub-Q fat because they're not eating, but they're gaining visceral fat because their cortisol is so high. That is metabolically active fat. And it drains directly into the liver because it drains into the portal vein, not into the systemic circulation. So a small amount of visceral fat will generate enough cytokines for your liver to be able to see it because it's concentrated, because it's not being diluted over the entire volume of distribution of your systemic circulation. So turns out about 5 to 6 pounds of visceral fat before your liver gets sick. So for sub-Q fat, 22 pounds. For visceral fat, 5 to 6 pounds. Now, can you see 5 to 6 pounds on the scale? Maybe, maybe not. Now let's do the third fat depot, the liver fat. The fat in your liver turns out to be the most egregious because it's right there. It's causing the problem, right where the action is, right there in your liver. Okay. It turns out only a half a pound of visceral fat. I'm sorry, liver fat, half a pound of liver fat,
Wow.
and you will end up with metabolic dysfunction, insulin resistance. Can you see a half a pound on the scale? No. All right. So 3 different fat depots. So the question is, what makes the liver fat? Answer, sugar. Because of this phenomenon, the de novo lipogenesis that we've been talking about. So you are mainlining it right into the organ that is the most susceptible to the problem.
Yeah.
And you can't even see it on the scale. So there are people walking around with fatty liver and don't know it because they say, well, I'm thin. No problem. Except they have a problem. And that's why 88% of Americans now have some form of metabolic dysfunction, because either sugar or alcohol is causing liver fat, irrespective of what it's doing the rest of your body.
Yeah.
And they don't know it. That's the nugget of truth that people, that doctors are ignoring.
Of course, that begs the question, how can people find that out? I will say, because we don't have much long left, I don't want to be respectful of your time, that in your book, there is a whole section on the various blood tests that you should go and get. They're very simple and actually very readily available. And actually, you did a beautiful section on, what the actual values are, but also what's optimal, what we should really be gunning for. Obviously, there's things like DEXA scans, there's waist to hip ratios that people can do.
Right.
But I guess, in my culture, a lot of people from my ethnicity are walking around. It was almost a joke growing up. Like you'd see dads, not a joke, but you'd see, dad's friends after they hit a certain age, they'd still be thin everywhere, but the belly would just start to go out. But thin arms, thin legs, just that belly. And of course, many South Asians do have an increased risk of TOFI, thin on the outside, fat on the inside, and all those sort of things. But I really wanted to highlight this because I think many of us think, it's all right for them. They can eat whatever they want and they don't put on weight. It's like, well, wait a minute. Yeah,
No,
cosmetically, they may not be looking, they may look as though they're getting away with it, but they may not be. I also just want to finish off on kids. You just mentioned liver fats. I've heard you say before that you've had to send 2 children at least for liver transplants because that is absolutely alarming, Rob.
From soda drinking.
From soda drinking. So maybe before we get to the final point, I just wonder if you could, there's many parents who listen to this podcast. And of course, a lot of people can take the advice for themselves. Right, I need to have a low sugar diet. I need to have high fiber, whatever my preferences are. But with kids, it seems to be quite different. Kids' meals are a joke in most places. It's like the adults can have proper food and the kids have the junk in bars and restaurants, right? It's the same in the US.
Chicken nuggets and French fries and a Coke.
So what is it doing to kids at this early age when they're having regular juices, regular soda drinks, regular highly processed foods? It's not really necessarily about their weight, is it? Is it setting the tone for later on in life? And then what advice would you give to parents?
First of all, sugar downregulates its own receptor on the tongue. So the more sugar, the less sweet. Therefore, you need more sugar. So it becomes a vicious cycle. That's one thing. Second of all, it still causes liver fat accumulation in kids. We, now have shown that 20% of children have liver fat unrelated to obesity. People, kids who have died in auto accidents, autopsies show 20% of kids have liver fat.
20%.
And it's unrelated to their obesity, to obesity. So where did they get liver fat from? They never had it before. This is where. The bottom line is that this phenomenon is also, the sugar is also causing changes in behavior. Now, we don't have enough time to go into this, but sugar inhibits an enzyme in the brain, in astrocytes, called glutamine synthetase. And glutamine synthetase is necessary to turn glutamate into glutamine, which then will go to GABA. Yeah. GABA is the inhibitory neurotransmitter. Glutamate's the excitatory neurotransmitter. So there's a balance between excitation and inhibition, and sugar basically breaks that balance. And so sugar's been associated with irritability. It's been associated with violent behavior. It's been associated with cognition problems. It's been associated with dementia in adults. It's been associated with changes in the prefrontal cortex thickness. It's been associated with problems in school. It's been associated with all sorts of problems. Now, association's not causation. Yeah. We are still working on putting all the causation pieces together.
Yeah.
So, I'm not here to tell you that sugar's poisoning your brain yet, but there's a lot of data, and the data in animals is pretty darn good.
Yeah.
You really want to go this route, people?
And you're not talking about just white table sugar. You're talking about the processed food. You're talking about the fruit juices.
Right. Absolutely. I'm talking about the Capri Suns. I'm talking about, the stuff that the parents are putting in the lunchbox.
Yeah. And that statistic, 20% of kids have liver fat. There could be parents listening to this who think my kids look fine weight-wise, so what's the problem with a glass of apple juice a day? And
that's the problem.
Yeah, exactly. And so this conversation is not meant to shame anyone. It's just meant to try and raise awareness of something that we both feel could be really, really helpful. Rob, I've got to say that if people want more, and I hope they do, well, at some point, if we can get a second conversation, I'd love that. But the book Metabolical it's really thorough. It's really comprehensive. I really would recommend people who want to learn more about this to get a copy. I think it's something you can keep dipping back in and out of over time. I really do think it's a fantastic read. And you cover the planet as well in it, which we didn't get a chance to talk about today. Just to finish off, this podcast is called Feel Better, Live More. When we feel better in ourselves, we get more out of our lives. And in view of everything you've said, in view of all your passion about this area, I just wonder if you could just leave my audience with some of your final thoughts and a few top tips that they can think about applying into their lives.
No, the most important thing people have to understand is, and you say it yourself, so I'm basically trumpeting what you say. To solve a problem, you have to solve the cause of the problem, not the result of the problem. Doctors don't know how to do that. And I can say that because I'm one of them.
Me too.
Okay. And I didn't understand that going through medical school, and I didn't understand that for the first 20 years of my practice. I did what I was told. I practiced the way they taught me to do. I got woke. You got woke. There are doctors around now who are getting woke, and they're starting to make some, shall we say, noise. They're being cast off as, heretics and, rabble rousers and, troublemakers and whatever. And some of them have even gone on trial in their respective countries. Tim Noakes in South Africa, Carrie Fetke in Australia, Evelyn Bordur-Roy in Canada. Don't know if there are any in the UK that have had that happen. But the bottom line is, we are undergoing a revolution in modern medicine. We underwent a revolution back in the 1930s, 40s with antibiotics, where we thought a pill could treat everything. Now we're undergoing a revolution where we realized that was a mistake. It's time to rethink health. It's time to rethink healthcare. You can't fix healthcare till you fix health. You can't fix health until you fix diet, and you can't fix diet until you know what the hell is wrong. And what you thought was wrong was basically propaganda for the last 50 years. We've had to undo that. We've had to basically turn it over. We've had to rethink all of modern medicine. And for your audience out there, what I'm telling you is not everything is wrong, but a lot of it is. When I went to medical school in 1976, a very, very famous clinician stood up in front of our class on the very first day, and you've probably heard this yourself, Rangan. He said, 50% of everything we teach you is wrong. We just don't know which 50%. This is the 50%.
Robert Lustig, you have been doing incredible advocacy for many, many years. You continue to do it. You're helping the lives of hundreds of thousands of people, if not millions, around the world. Thank you for joining us on the podcast, and hopefully we'll get a chance to talk again in the future.
It's my pleasure. Hope to come to the UK and we'll have a beer. Just one.
Data shows that it is your liver and visceral fat that determine your health, not your weight or total body fat.
Stand by that. That's exactly right. It's not the fat you can see that counts. It's the fat you cannot see. And the reason is because those fat depots have different causes, different effects, and ultimately different drainage. And the drainage is actually the important thing. So let's go through those 3 fat depots that you just mentioned and what causes them and what consequences there are for them. So the first fat depot is the one that's obvious, the one you can see. Subcutaneous fat, big butt fat. Subcutaneous fat is where your body wants to store fat. And there's a lot of it, all right? And it has big vacuoles. In other words, the place where the fat actually gets stored inside each of the adipose tissue cells. Now, it is possible to overstuff each of those vacuoles. And when you overstuff each of those vacuoles and you put down more and more subcutaneous fat, there is the possibility that that fat vacuole will expand and expand and expand. And the perilipin border that surrounds that fat vacuole will be stretched and stretched and stretched so severely because that fat vacuole has just gotten so big, you know, like a balloon that's about to burst. And what happens is that when that happens, the perilipin border can't hold it anymore, and the fat starts to leak out into the adipose tissue cell, choking it off and killing it. And so now you have a dead adipose tissue cell with a whole lot of grease that has to be cleaned up. That sends out messages to the macrophages, the cleanup crew, which comes and then populates that fat and starts actually cleaning up the grease. And then that sends out inflammatory cytokines, and that is what starts the inflammatory response. Now, when that happens, the drainage of that adipose tissue, that subcutaneous adipose tissue, goes where? It goes into the entire systemic circulation. It goes into the inferior vena cava and therefore circulates throughout the entire body. So the volume of distribution is the volume of distribution of your blood supply, which is 6 liters. In other words, you have to cause a lot of inflammation in a lot of adipose tissue to be able to generate a concentration of cytokines that's enough to actually do damage to the rest of the body. How much? Maybe 10 kilos, 22 pounds on average, maybe a little more for certain races, maybe a little less for others. Okay, so is subcutaneous fat bad? And the answer is, when it gets super big, sure, but in general, no. In fact, that's the safe place to put the fat. Mm-hmm. Now let's take fat depot number 2, visceral fat, belly fat. Now, what causes belly fat? Stress. Stress causes belly fat. Food? Does food cause belly fat? Turns out, no, food does not cause belly fat. Stress causes belly fat. And the reason we know this is because you can take patients who are suicidal with major depressive disorder that have to be admitted to the hospital to keep them from killing themselves, stick them in an MRI scanner, and you can see that the subcutaneous fat's going down because these are people who are anhedonic. They are not eating. They are losing weight. Losing weight is one of the cardinal features of major depressive disorder because you don't want to eat because you want to die. But visceral fat is going up. You are reapportioning the subcutaneous fat to the visceral fat, despite the fact that you're not eating and you're losing weight. So that visceral fat is driven by cortisol. It is driven by stress. It is not driven by food. And when that fat gets too big, it starts releasing fatty acids and cytokines, and then that goes straight to the liver because the drainage for the visceral fat is the portal vein, and it goes straight to the liver. And so what's the volume of distribution then? Not 6 liters, more like 250 cc's. And so a little visceral fat will increase the concentration reaching the liver by a lot. Okay. And how much visceral fat can you gain before you start getting sick? About 5 pounds. So about 22 pounds for subcutaneous fat, about 5 pounds for visceral fat. And then finally, fat depot number 3, liver fat. And that liver fat is the worst because it's actually the fat right at the center, at the nidus of where the problem is. Because when your liver is sick, all hell breaks loose because that's the thing that drives the hyperinsulinemia the most, because the pancreas has to basically tell the liver to do its job. And so the insulin levels go straight up based on the fat in the liver. And how many kilos or how many pounds of fat can your liver hold before it gets sick? About 0.5 pound. So 22 pounds of subcutaneous fat versus 5 pounds of visceral fat versus 0.5 pound of liver fat. And where'd that liver fat come from? Alcohol and sugar. So different fat depots, different risks, different drainages, different consequences.
Mm-hmm. I mean, it's fascinating. Thank you for going through those 3 different fat depots. I really enjoyed reading that section in the book, actually, and it was so striking when you pointed out, as you just have now, that, yeah, the subcutaneous fat is where we are designed to put excess energy that we take in. In the olden days, in the summer, we'd store the fat and it would get us through the winter, right?
Exactly.
That's not a problem for our health unless it goes beyond that sort of natural capacity. Then it starts to become problematic. Yeah. Then you mentioned the visceral fat. Now, hopefully listeners of my podcast have heard that term several times before, and we did touch on it in our first conversation together. Mm-hmm. But that idea that visceral fat is driven by stress and not by food, that's quite interesting because, let's say someone had no stress at all in their life. I don't know anyone living in...
I was going to say, I'd like to meet them.
But let's just, hypothetically speaking, someone has, minimal stress in their life, but they are consuming energy in the form of food to excess. Are you saying that, in your view, unless there's also some kind of chronic stress on board, then that food, that excess energy will be stored as subcutaneous fat or potentially liver fat, but it won't be stored as visceral fat without the stress?
Exactly. That's exactly what I'm saying. And the reason is because in order for that visceral fat to accumulate the fat, there has to be something wrong with the sympathetic nervous system.
Sorry to interrupt. If you're enjoying this video and want to dive deeper into the topic of nutrition, I have created a free special guide which contains the 5 most important changes I think we all need to make when it comes to our diet. If you want to get hold of this free guide, all you have to do is click on the link in the description box below.
So that sympathetic nervous system is what's driving that adipose tissue fat depot. Now think about this. This is actually very important. The visceral adipose tissue has the beta-3 adrenergic receptor. Every single cell has the beta-3 adrenergic receptor. So it is taking information from the sympathetic nervous system. Okay? And every cell has an adrenergic innervation. So when you are acutely stressed, message goes from the locus ceruleus in the brain via the intermedial lateral cell column of the spinal cord out to, the various peripheral nerves like the celiac nerve and the superior mesenteric nerve to the visceral fat and sends a norepinephrine signal. And that norepinephrine signal says to that fat cell, give up your fat because we are in a stressful situation and we need energy. And so stop accumulating fat energy and start releasing it. And so you hit the pause button on lipoprotein lipase, which is making the fat, and you hit the go button on the hormone sensitive lipase, which allows for the extrusion of free fatty acids, non-esterified fatty acids from that visceral fat, which then goes into the circulation, goes to the liver, and can either be manufactured into glucose or ketones for energy for the rest of the body. Okay? That's the acute stress response. So the acute stress response, by stimulating norepinephrine, causes the visceral fat to give up fat. It is lipolytic. It is, a fat losing in the visceral compartment. But chronic stress does the opposite. Now, how does chronic stress do the opposite? Why does chronic stress do the opposite? Chronic stress causes that visceral fat to accumulate instead. So, number one, chronic stress has cortisol. Acute stress, you haven't gotten a cortisol bump. It takes 10 minutes to generate a cortisol bump in response to an acute stressor. Okay, it's a norepinephrine response. And your adrenal gland doesn't have any cortisol stored. It has to make cortisol de novo from scratch, from cholesterol, because there's no storage place for cortisol. So cortisol's always a delayed response. It comes in around 10 minutes. So for those first 10 minutes of an acute stress, the lion chasing, the pygmy on the savannah, okay, that's all norepinephrine. Mm-hmm. And so you're going to get all hormone-sensitive lipase activation. You're going to get all that fat rushing out of the visceral adipose in order to generate the energy that the body needs to run away from the lion. All right? But then cortisol kicks in. And cortisol does something very different. Cortisol alters mitochondrial function. Cortisol also increases the enzymes that then lay down fat. And then something even more remarkable happens. I'm sure you're aware, Rangan, that every adrenergic neuron in the body, whether it's in the brain or in the periphery, releases norepinephrine, and it also releases a second neuromodulator, a neuropeptide. And that neuropeptide is called neuropeptide Y, NPY. Okay, and they always are co-localized and they always are secreted. It turns out NPY is the brake on the adrenergic nervous system. So the adrenergic nervous system is telling that fat cell, release, 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 release. And then NPY is co-released, and it basically tells that fat cell and every other organ in the body, calm down, I'm the brake. If you keep doing this, we're going to get into trouble. And so NPY binds to the Y2 receptor on that visceral fat cell and actually stops the process and actually starts promoting lipogenesis again. So in the face of chronic stress, you've got cortisol and you've got NPY antagonizing that lipolysis, and it actually converts it to lipogenesis. And that's why acute stress and chronic stress are virtual opposites.
Yeah, it's absolutely fascinating. And there's a wider point for me. In the modern world today, in 2024, there are so many different factors that are working against us when it comes to health.
Mm-hmm. You bet.
It's easy to put it all in one area and, for example, say it's the food. Now, I don't deny that the food is a huge problem, but as well as a lot of us having access to energy-dense, very tasty, nutrient-poor foods, which we know and we'll definitely be covering in this conversation again, we're also not moving much at all because of our jobs and the way we travel and move around. We're sleep deprived, which we know in and of itself can cause insulin resistance. Sleep deprivation is a stressor.
Cortisol rise.
Exactly. It's a stressor in and of itself. And so if that's chronic sleep deprivation, that is a chronic stressor on the body.
Absolutely.
But then you also have, just looking around, people feel rushed. They feel busy. They don't feel they have time. 6-7 years ago, the World Health Organization put on their website that stress is the health epidemic of the 21st century. It's no wonder that people are struggling. It's no wonder that people are sick, because it seems as though for many of us, every single input coming into our bodies from our environment is not exactly helping us, is it? It's actually getting in the way of our overall health. But I guess fundamental to what you're writing about in your book, it's getting in the way of metabolic health, which really is health.
I hate to tell you, but it's not just getting in the way of metabolic health. It's getting in the way of mental health. It's getting in the way of global health. It's getting in the way of planetary health. It's getting in the way of everything. So I'm glad you brought this up, because I wanted to talk about this with you. So this is reciprocal. So this is good. 4 years ago, just before COVID hit, I won a Fulbright to study in Paris. And I had two jobs. One, unfortunately, when COVID did hit, I had to leave and, go back to the US. But the second project has continued online, 2 hours at a time, 2 days a week for the last 4 years. So I have been working with a French colleague, and he is very interesting. His name is Professor Philippe Gaussier, and he is both a robotics professor and neuroscientist at the Université de Cergy-Pontoise, which is about 17 miles northwest of Paris, in a little town called Cergy. And he has a very unique skill set, robotics and neuroscience. And his job, his goal, is to make robots behave more like humans so that they would be more acceptable to humans. Now, in order for him to do that, he has to understand emotion. And so there are all of these, neuroscientists out there studying the anterior fossa and, neural networks and cognitive function and learning and, machine learning and AI and what have you. But almost nobody is studying the posterior fossa, the emotion part of the brain. And so we went out to build a computational model of the limbic system. And we have. And it's taken us 4 years, but it's pretty darn good. And it actually works. And it's pretty cool when you actually look at it, because what we've come to realize through the building of this model is that it's really about one area of the brain, the amygdala. Now, the amygdala, for your audience, is the fear center of the brain. It is the stress center of the brain. And here we are talking about, chronic stress. It is about amygdala dysfunction. And the point is, it's not the amygdala that is dysfunctional. The amygdala is actually doing its job. But what we've learned is that there are 4 brakes on the amygdala. And those brakes are not doing their job. They're what's dysfunctional. So think of it this way. You have a car, okay? And the car has 4 wheels, and each wheel has a brake. So there are 4 brakes on the car. You step on the brake in the cabin, and all the wheels stop at the same time, and you stop and then you go. All good. Now imagine one of those brakes fails. You hit the brake, what happens? Are you going to stop? Yeah, you'll stop, but it's going to be a pretty rough ride.
Yeah.
Now imagine 2 brakes fail. You're going to stop? Yeah, you'll still stop. If the 2 brakes that fail are in the back, you'll glide to a stop. If the 2 brakes that fail are in the front, you're going to lurch to a stop. But what if the 2 brakes are on either side of the car? You're going to do a 360 and possibly damage. All right. Now, what if 3 brakes fail? Are you going to stop? You're going to capsize, but you'll stop.
Yeah.
And what if all 4 brakes fail at the same time? You are over the precipice and into the abyss, like the last scene of Thelma and Louise. Well, that's what's happening to us, because all 4 brakes on the amygdala are failing at the same time. So what are those 4 brakes, and why are they failing? So the first one is prefrontal cortex, reasoning. And the reason for the failure, both cortisol and dopamine, okay, which are both, just gigantically elevated in our society. The second brake, the hippocampus, memory. And why is that failing? Also cortisol. Cortisol causes increased energy need, and that's not being supplied. And so you've got hippocampal atrophy. Third brake, the afferent vagus. The afferent vagus normally conducts neural impulses from the entire abdomen, including the gut, all the way up to the nucleus tractus solitarius, and then a way station up to the amygdala. Well, what is that? That is where the serotonin goes from the gut up to the brain. And so that is part of what we call interoception, your body's being able to actually monitor itself. Problem is, if you're eating ultra-processed food, those microbes can't make serotonin right. And if you're eating ultra-processed food and you're insulin resistant, your liver's taking the tryptophan and turning it into kyurenine instead of serotonin. And you're not even getting levels up into the brain that you need. So basically, no tryptophan, no serotonin, no break. And then finally, number 4, which is really exciting, oxytocin. So everybody thinks of oxytocin as the love hormone or the reproduction hormone or the milk ejection hormone. It's all of those things, but it's also the safety hormone. It's the thing that transduces the feeling of safety. And it's epigenetic because the oxytocin receptor is the most easily methylated protein in the brain. And all of these stresses like adverse childhood experiences and traumas and what have you, all end up methylating that oxytocin receptor so that you can't get the feeling of safety. You are under constant and chronic threat. And that is the 4th brake on the amygdala. And that's what everyone's complaining about, is that they don't feel safe.
Yeah.
And so all 4 brakes are failing at the same time. And so the amygdala has run hog wild.
Yeah.
And it is the driver of our systemic health crisis through all the processes we just discussed, the mental health crisis, the depression, the PTSD, the global health crisis, in terms of social disparities and corporate determinants of health. And it is also the driver of the planetary health crisis in terms of inequality, war, and climate change.
I mean, thank you for sharing that. That's so interesting. As you were describing those 4 breaks that no longer work well at all for many of us, I was thinking about a thought experiment that I often do. A few years ago, set out this model of the 4 pillars of health, right? Food, movement, sleep, and stress being the 4 areas that not only have the most impact on our short-term and long-term health, but also they're 4 areas that we have, a fair degree of control over, although that is arguable depending on your life circumstance. And I often ask myself, which is the most important? And I know it's a bit of a ridiculous one because they're all important, right? And it's going to depend on the individual as to what's going on in their life, which is the pillar that they probably need to address the most. But often I come to the conclusion that for many people, most people, the stress pillar might be the most important one. And the way I sort of justify that is not only does chronic stress impact every single organ system in the body negatively. We could spend half an hour just talking about what chronic stress does to the body.
Absolutely.
But also if we think about food, well, these days we're not always eating because of physical hunger. We're often eating because of emotional hunger. So chronic stress is driving us to comfort eat and eat more of these so-called unhealthy foods than if we weren't feeling so stressed. So what I'm trying to get to, Rob, is this idea that being under chronic stress drives so many problematic behaviors. You've spent a lot of your career raising awareness about the problems of too much sugar, the problems of highly processed foods. How do you think about food and stress in terms of their relative importance?
The fact of the matter is that virtually everyone, including myself, are stress eaters. Yeah, there are a few people out there who are, who stop eating because of stress, but most people are actually stress eaters. And there's a reason, is because there's a pathway of reward suppressing stress. Okay. This is one of the pathways in the nucleus accumbens to calm it down. So dopamine is an excitatory neurotransmitter, and it sends its paracarrier in the ventral tegmental area, the back of the brain, and it sends the processes to 2 places, just 2 places. The first is the nucleus accumbens, the reward center, so you get a feeling of reward. And then the second is the prefrontal cortex. Okay, now the prefrontal cortex is then supposed to send information back to the nucleus accumbens, basically calming it down. Okay, yeah, I love this chocolate, but you know what? I don't need to eat any more of that. All right, that's the reciprocal relationship that's supposed to occur between the reward system and the reasoning system. Well, that is broken. And what broke it? Cortisol. Because cortisol causes the atrophy, the cell death and atrophy of those neurons in the prefrontal cortex. You can actually see it on magnetic resonance imaging. You can actually see the reduction in volume in the face of chronic stress. So, and in the face of obesity. So we know that this level of cognitive inhibition that normally controls that reward system has basically been, taken offline.
Yeah.
And that's the whole point. That's one of the 4 breaks that you're describing. So this is not surprising or even remarkable for that matter. And this has actually been known for 40 years. This is work Robert Sapolsky did way back in the 1980s when he realized that the hippocampus was the most vulnerable part of the brain to energy deprivation. And, that those neurons would die quickest. And the reason is because the mitochondria are being altered by cortisol so that they do not produce as much ATP. So they need more glucose in order to be able to survive. And so that's one of the reasons why you keep eating when you're stressed, is because you're basically trying to feed those hippocampi to keep them from dying.
Yeah. You know, Rob, I think the first time I really became aware of this, and it's interesting hearing you talk about these 3 fat depots in the body, because I'm drawn to several previous patients, and they all had a particular pattern. And then maybe this is about 10 years ago when I first started to see this and observe this and go, wow, stress is really playing a role here in terms of fat accumulation on the body. And it would typically be women, I would say in their mid to late 40s, who I was seeing. Often they were mothers. And of course, yes, that is a time when they could be going through hormonal changes and, you know, premenopausal and menopausal for sure. But what I would see with these particular patients is that they were eating pretty well, actually. They were trying their best to eat well, but they had a stressful life, a very busy life, and they were pushing themselves at the gym with lots of intense cardio. And I remember with one patient once thinking, okay, look, this just feels like there's too much of a stress load on your body. And I remember one patient in particular who I advised to stop doing intense cardio. And I said, honestly, I feel that you need something more relaxing for your movement, like yoga. And she was quite skeptical at first, but within weeks of stopping the intense cardio and doing, I think it was 2 yoga classes a week she would do after work on the way home, the weight around her belly started to come off. And I remember seeing that pattern. And I think that's very, very common. And I think, you know, in this era of health information overloads with people consuming, you know, all the time podcasts and YouTube videos and trying to learn, which I think is great on one level. I think one of the downsides sometimes is that people think they need to keep doing more and more. Wow, I need to do that exercise. I need to add that in to an already busy life. They're adding in more and more stress. So, you know, it kind of fits in with what you just described, right?
We didn't see it. We studied it. And we had a whole study here at UCSF called the SHINE study, where we did just that. We took peri and postmenopausal women, okay, with metabolic syndrome, and we divided them up into 3 groups. 1, a standard exercise regimen. 1, a mindfulness-based stress reduction regimen. Mm-hmm. Okay, so basically meditation, okay, i.e. yoga. And number 3, control. And asked the question, what happened? And it turned out that weight did not change. We were hoping weight would change. Weight did not change. But what did change was visceral fat, waist circumference, and insulin sensitivity. And we're well, you know, we had papers in JAMA. You know, bottom line is we know that stress is the bad guy. It's not the only bad guy. Mm. Okay. There are other bad guys. I mean, bad food is a bad guy, and stress basically makes you eat bad food too. Okay. But stress is a primary factor on its own. And the problem is that people don't know how to mitigate their stress. And they are actually prevented from mitigating their stress because our society doesn't allow them to do otherwise.
What are the key negatives when we consume the levels of sugar that many of us are currently consuming?
Well, first of all, let's make it very clear that sugar is not the only problem in our diet. It's the big one. It's the 2,000-pound gorilla in our diet, but there's other stuff too. But sugar is a particularly egregious molecule. Once upon a time, trans fats were the worst thing we consumed. Trans fats are the devil incarnate. Trans fats, the bacteria can't chew it up, which is why they put the trans fats in, all right, so that, you know, it would last forever, you know, the 10-year-old Twinkie. Well, the fact is our mitochondria, our little energy-burning factories inside all our cells, are really refurbished bacteria. We can't chew it up either. So the exact same reason for why they put the trans fats in the food is exactly why you shouldn't eat the food. Now, we know that, and they've come out of our diet. So now sugar is public enemy number one. So what does sugar do? And the answer is a whole bunch of bad things. The food industry says sugar is energy. Well, they're correct if you're a bomb calorimeter. If you just blow it up, if you explode it, yeah, you get 4 calories per gram. But we are not bomb calorimeters. Turns out that sugar actually poisons the mitochondria. Okay, it poisons it at 3 separate enzymes that are necessary for mitochondria to do their job. The first one, AMP kinase, which is the fuel gauge on the liver cell. The second one, ACAD-L, acyl-CoA dehydrogenase long chain, which is necessary to get fatty acids into the mitochondria to be able to oxidize them to create energy. And the third one is CPT1, carnitine palmitol transferase 1, which is the enzyme that regenerates carnitine, which is the shuttle mechanism that brings the fatty acids into the mitochondria in the first place. In other words, when you consume sugar, you are poisoning your mitochondria. You are generating less of the chemical energy that our cells get powered by, called ATP. So if you're making less ATP, is that energy? It's the opposite of energy. So when you consume sugar, you are actually inhibiting your body's energy production. Can you think of a chemical that inhibits your mitochondria and reduces ATP production? Cyanide. Cyanide does that. Okay, sugar and cyanide do the same thing. Now, obviously, not as severely. Okay, cyanide parts per million keel over and die on the spot. With sugar, it's in the parts per 1,000, and you don't keel over on the spot, but you feel lousy, and over time, it's going to take its toll. But ultimately, if you're inhibiting your mitochondria, you are poisoning your body. And we now have the data to show how that occurs. So here's my question to you and your audience. Sugar is in virtually all ultra-processed foods, and ultra-processed foods are now 56% of the UK diet, and the amount of sugar that Brits eat, 62% of it is found in the ultra-processed food category.
Wow.
So my question to you and your audience is ultra-processed food food?
My view is that it's not really. I would say no, but I know to many people that is super controversial, which we're definitely going to talk about. But yeah, on a straight answer, I would say no. Depends on your definition, I guess, because it's energy. Okay. It's got some calories in it, which we consume in our mouth that enable us on one level to sort of, I guess you're saying it's actually reducing the energy production, the sugar within it anyway. But yeah, on one level, it sustains people and they can actually get on with their days, at least in the short term anyway.
Well, you have to know what the definition of food is. So if I had my Webster's dictionary right here, right now, you guys, in the UK probably don't use Webster's, you probably have something else. But if I pulled it off the shelf, it would say that the definition of food is the following, and I have no problem with this definition. Substrate that contributes to either the growth or burning of an organism. That's the definition. I have no problem with that definition. It's a fine definition. All right. Substrate that contributes to either the growth or burning of an organism. So we've just talked about burning. Sugar does not contribute to the burning of an organism. It actually inhibits the burning of an organism. And Dr. Kevin Hall at the NIH did a study where he showed that when you give people ultra-processed food, they burn less and gain more weight when everything else is controlled for compared to the same diet in real food. Did this in 2019. So ultra-processed food does not contribute to burning. So now let's go to growth. Does ultra-processed food contribute to growth? My colleague, Dr. Efrat Monsenigo-Ornan, who is the chairman of the Department of Nutrition at Hebrew University, Jerusalem, just published 3 papers in Bone Research showing that ultra-processed food actually inhibits skeletal growth.
Sorry to interrupt. If you're enjoying this video and you want to learn more, then do check out my free special guide, which contains the 6 crucial steps you need to take in your life to not only build healthy habits, but also to make them stick. If you want to get hold of this free guide, all you have to do is click on the link in the description box below.
Inhibits the ability of bones to increase in length and in width. And in addition, we know from the Nutrinet Santé study and many other studies that, in fact, what sugar does is it feeds cancer cells, it hijacks growth. So, sugar doesn't contribute to burning, inhibits it, doesn't contribute to growth, inhibits it, or hijacks it. So I pose the question to you again, Rangan. Is ultra-processed food food?
I'll go with my original answer, which is no.
That is right. It is no. Ding, ding. That's right. But the point is that the food industry, refuses to go there. The populace refuses to go there. The governments refuse to go there. And you and I are both interested in mitigating chronic disease.
Yeah.
And you are right. If you get people on a real food diet, you can mitigate virtually any and all of their chronic diseases. I completely agree. You gave a TEDx talk basically saying you can basically take away somebody's chronic disease. I used to do that in my clinic, when I was practicing routinely.
Yeah.
But only if they changed the food. And if they didn't change the food, no amount of medicine I threw at them could make a difference.
Yeah, I mean, what strikes me as a really key message is that the majority of what we're buying to feed ourselves and our families is ultra-processed food, whether it's here in the UK or with you in America. And that is contributing to this tsunami of chronic ill health that we're seeing. It's pretty alarming. But what I think is so key, Rob, for me, is that it's so normalized now. Like it's the norm everywhere, schools, hospitals. In fact, if you want to go down the real food route, you almost feel like a bit of a, if you try and do it with your kids, you actually become a social outcast in some ways.
You're a pariah.
And I think this is the problem. It's the norm. We've moved so far away from what we used to do. In fact, maybe this is a good time for you to explain what you used to do when you were 8 years old, because I believe you had a granddad who lived in Brooklyn. And every Saturday you would do something which I think beautifully illustrates this point.
That's right. So bottom line is I completely agree with you. What we've done is we've normalized it. Once upon a time, it was actually not normal to eat ultra-processed food. And today it is normal. And I remember when that happened because it happened to me. It happened to me in 2 ways. So on Saturday afternoons, my family would go visit my grandparents who lived about, 8 miles away in Brooklyn. And my grandfather would walk me down to the corner grocery store to buy a comic book and a 6.5-ounce bottle of Coca-Cola. And I remember, pretty much every Saturday afternoon. And that was the big treat, the comic book and the Coca-Cola. That was on Ocean Avenue and Avenue N in Brooklyn. The fact is that was once a week and it was 6.5 ounces. All right. Today, children are consuming about, I think, 35 ounces a day, median. So they are getting about 6 times the amount of sugar that I did from that one Coke. And they're doing it every day instead of once a week.
Can we just pause on that for a second? You're saying you had 6 ounces once a week, and we're assuming back then that the rest of your diet throughout the week was low in sugar, low in processed foods, sort of a real food diet?
Well, my mother worked 3 jobs. And so I ate a lot of Swanson TV dinners when they first came out. And I remember when they came out around 1964, you know, the fried chicken, the Salisbury steak. I hated that Salisbury steak. And she trained me on how to turn the oven on and how to heat them up, because often she wasn't home at night. You know, so, you know, to some extent, I was a latchkey kid because my mother worked so hard.
Yeah.
You know, my father was in Manhattan all day. And so, you know, I basically had to sort of take care of myself. And sometimes I had to eat dinner, you know, out of the freezer. And so I remember, you know, those Swanson TV dinners, and, you know, they were a problem, and they're still a problem. So you put the two together, and that was the beginning of, you know, the, shall we say, onslaught of processed food in the United States about the mid-60s. Then things picked up even more in 1975, when we started substituting high fructose corn syrup for sucrose, because it was half as expensive and it was homegrown. And then finally, the pièce de résistance came in 1977, when the McGovern Commission released its report saying that we all needed to eat less fat to try to prevent cardiovascular disease. Well, when you take the fat out of food, it tastes like cardboard. And so what did the food industry do? It basically replaced the fat with sugar. That's why we ended up with Entenmann's fat-free cakes and, you know, and the like. And that was when the pasta craze, you know, first hit, was, you know, refined carbohydrate, because it was, quote, low in fat, et cetera. And, you know, now we're off to the races. And it's just exploded ever since.
Is it the sugar that's inherently bad in and of itself, or is it the excess amounts? I mean, or is it both, right? Because I think a lot of people might say, well, look, you know what, this never used to be a problem, right? And we would have the odd sweet treat now and again. But so, and actually there's quite a few prominent scientists, as you're well aware, Rob, who say actually sugar's not a problem. Sugar's actually completely fine.
Yeah, we're working on it. I have a bone to pick with some of those scientists, and we can argue that and talk about that if you like, as to exactly why they say what they say. So here's what I can tell you. All right. There are social drinkers and there are alcoholics. Now, social drinkers can pick up a beer and put it down, and they don't need one every day. Alcoholics pick up a whiskey and can't put it down, and they need it 3 times a day. Right?
Yeah.
Did the one beer that the social drinker drank hurt them?
Unlikely.
Unlikely. And the reason it's unlikely is because there is what is known as a first pass effect. You drink the alcohol in the beer. First of all, it's very low percentage, right? It's only about 3.6% in a beer. All right, and that is about 60 calories worth or so of alcohol. And what happens is that the first pass effect, the stomach and intestine metabolize that alcohol before any of it ever gets to the liver. And so the amount that actually hits the liver that could do damage is exceedingly small. And as long as you're not following up with a second beer and a third beer and a fourth beer and a fifth beer, you know, like can happen at the Newcastle pub, you know, you don't usually have a big problem, right? But if you keep doing that, then that is a problem. So it's a dose-dependent phenomenon, and your intestine is there to try to protect your liver from getting the onslaught before it will do damage. Same with sugar. No difference. So your intestine can take a small amount of sugar that you consume and can actually turn it into fat in the intestine. Intestinal de novo lipogenesis, the process of converting sugar to fat into VLDL in the intestine, so that it will not go straight to your liver. right? And about 10% of an initial sugar bolus will undergo intestinal DNL and therefore be diverted away from the liver and into the bloodstream as VLDL. Now, that VLDL is not great for you because it could ultimately cause heart disease, but it's protecting the liver. But if you consume past your intestine's capacity to do that, now the rest of it's going to end up in your liver. And the problem with sugar in the liver is exactly the same as the problem of alcohol in the liver, because it causes the exact same processes. It causes glycation, it causes oxidative stress, it causes mitochondrial dysfunction, and basically drives insulin resistance, this phenomenon that we now know is at the base of virtually all chronic metabolic diseases. Therefore, your pancreas has to make extra insulin to make the liver do its job, because now the liver's not working right because it's been poisoned. And so insulin levels rise all over the body. And now you've got, the risk for Alzheimer's, you've got the risk for heart disease, you've got the risk for cancer, you've got the risk for virtually every other chronic metabolic disease on the plate, all because of what happened to your liver.
Yeah.
And fructose, that sweet molecule in sugar, basically has the same fate as alcohol. So when people say, oh, well, little sugar's fine, the answer is, yeah, because your intestine diverts that little bit away from the liver. As soon as you overwhelm that capacity, now your liver is right in the crosshairs. And that's when chronic disease is going to start.
Yeah. Rob, you're a pediatrician. I've seen videos of you talking with passion about this exact topic, maybe 15 years ago, still online.
Something like that.
When was the first time for you that you started to think, what's going on here? In the book, you have been pretty, it's pretty provocative at times. I actually agree with it. So I like it. You've really gone out there. You've ripped into modern medicine at times, and we're definitely going to talk about that.
Yep.
But when was it, because you do have this sort of incredible passion and energy to get this message out there. And I'm just wondering, what was it in your clinical experience that actually really got you into thinking there must be another way here? This can't be right.
Right. Well, so I had 3 aha moments. 3. And that sort of got me to where I am today and why I'm saying what I am saying today. The first aha moment came when I worked at St. Jude Children's Research Hospital in Memphis, Tennessee, pediatric cancer hospital. And I went there in 1995, and I was presented with a cadre of about 40 children who had survived their brain tumors, because of surgery and radiation, sometimes chemotherapy, who had become massively obese. They were perfectly normal weight before the tumor, and now they were on the order of 350 to 400 pounds. Okay, normal kids before the tumor, and now massively obese. And there's a name for this. It's called hypothalamic obesity. It was first written about, first described in 1901 by Freilich and Babinski, 2 of the greats of international neurology. And I had all these kids with hypothalamic obesity that I had to take care of. And how do you get them to lose weight? How do you get them to get better? And it had been shown previously that diet and exercise is useless. In fact, George Bray, the father of obesity research in America, in 1975, had taken 8 of these kids on his ward and fed them 500 calories a day for a month. What do you think their weight did?
Well, you would expect it came down, but I suspect in this case it probably didn't.
It went up.
Yeah.
Okay, 500 calories a day, and their weight went up. How does that happen? And the answer is it happens because they were burning it slower than they were taking it in, because their metabolism of calories had actually come to a virtual standstill. So even 500 calories a day was too much. And these kids have like no energy. They sit on a couch. They're not interested in anything. The parents would actually complain that that was the worst thing about this. They'd say, this is double jeopardy. My kid has, survived the tumor only to succumb to the therapy, because my kid is a lump on a log and he's lost interest in everything. He's lost interest in school. He's lost interest in life. He's lost interest in activity. He's lost interest in friends. He's lost interest in everything. All he wants to do is sit and sleep. And so I had to take care of these kids. So I went to the literature and I said, the other thing was that this was exactly when the hormone leptin had been discovered. Leptin was discovered in 1994. And I was prepared for that discovery because I worked at Rockefeller University with the guys who discovered it, Jeff Friedman and Rudy Leibel. Okay, we were all the MDs at Rockefeller University, all had to take call in the hospital together. So we were always trading, call dates and everything. So everybody knew what everybody else was doing. So I knew that they were trying to clone this, this hormone, out of these mice. And so when they did in 1994, I was very prepared for it. So I moved to St. Jude and I had these kids, and it's like, what am I going to do for them? And I postulated right then that these kids must have leptin resistance. These kids can't see their leptin. And the reason is because their hypothalamus is dead, because we killed it because of the tumor or the surgery or the radiation. And so because they can't see their leptin, their brain thinks they're starving. So the question was, okay, their brain thinks they're starving. What's downstream of leptin? What's actually making them gain the weight? The starvation's why they're hungry, but what's making them gain the weight? Well, we knew that these kids made a lot of insulin. And we knew that there's this animal model of damaging the hypothalamus, and they put out enormous amounts of insulin. And you could actually stop that by cutting the vagus nerve. The vagus nerve is the nerve that leads from the brain to the pancreas, and then the insulin would go down. So I said, well, I can't cut their vagus nerve. I'm not a surgeon, and that's a little drastic. But what if I gave them a medicine that suppressed their insulin release? And so we gave them a drug called octreotide, a drug that is used by endocrinologists to usually suppress growth hormone release, but it also suppresses insulin release. So we repurposed it and we gave it to these kids. And lo and behold, they started losing weight. And they couldn't lose weight before. George Bray showed they gained weight, but they were losing weight. And something even more remarkable happened. They started exercising spontaneously. One kid started competitive swimming. 2 kids started lifting weights at home. 1 kid became the manager of his high school basketball team, running around collecting all the basketballs. I mean, these were kids who sat on the couch, ate Doritos, and slept. And now they're active again. And the parents would say, oh my God, I've got my kid back. And the kid would say, this is the first time my head hasn't been in the clouds since the tumor.
Yeah.
So something had changed their relationship to the world. Not just their relationship to food, but their relationship to the world. So we said, this is very interesting. So we did a double-blind placebo-controlled trial, and this time built a quality of life measure into the protocol. And sure enough, the lower we got the insulin with the drug, not only the more weight they lost, but the more active they were. So what this did, the reason why this is so important and the reason I'm spending so much time on it, Rangan, is because this turns the first law of thermodynamics on its head. Because the standard interpretation of the first law goes like this. The first law is, the total energy inside a closed system remains constant. Energy can neither be created nor destroyed, just shifted around. Okay. The standard interpretation that we learn in medical school and what the general public learns is if you eat it, you better burn it or you're going to store it. In which case, the storing part, the fat gain, is secondary to the primary problems, which are the eating and the burning, the gluttony and the sloth. Therefore, the weight gain is secondary to the gluttony and the sloth. Therefore, it's about behavior. Fix the behavior, fix the weight. What we showed in these kids was it's exactly the opposite. Turn it around. What we showed was if you're going to store it, that is a high insulin level leading to obligate weight gain, and you expect to burn it, that is normal energy expenditure for normal quality of life, because energy expenditure and quality of life are synonyms for each other, then you're going to have to eat it. And now the storage is primary and the behaviors are secondary. The gluttony and sloth are actually because of leptin resistance.
So we get sick first and then the weight comes afterwards.
That's right. We get sick first and the weight is secondary. That's exactly right. So this is, monumental. This is huge. But of course, it goes against everything that we are taught, and it goes against everything that, doctors routinely believe. But this was my first aha moment. My second aha moment came in 2006. So I realized that insulin was the bad guy, and we started then changing what we did in clinic. Instead of worrying about weight, we worried about insulin. We said, get the insulin down any way you can. And that's what my clinic became. It became an insulin reduction clinic. It wasn't a weight loss clinic. It was an insulin reduction clinic. And when we got the insulin down, then they lost weight. So in 2006, I was asked to give a talk at the NIH, specifically the National Institute of Environmental Health Sciences in Research Triangle Park, North Carolina. They were having their 100th anniversary of public health. And it was a 2-day symposium. The first day was on their successes, like lead poisoning and pollution and asthma, things they'd figured out and, been able to do something for the public health. And the second day was on challenges. And the morning was going to be obesity, metabolic syndrome, and the afternoon was going to be ADD and autism. Okay. So they asked me to give a talk. What do you think is the single most important environmental exposure that leads to obesity and metabolic syndrome? And I figured that they probably figured I was going to, give a talk about some, like BPA or some other, environmental, toxicant, that's in the water or in the air or, something like that. And I thought to myself, how am I going to, make this worthwhile? And I thought to myself, all right, wait a second. Let's go backwards here. Children today get 2 diseases they never got before: type 2 diabetes and fatty liver disease. Those 2. Children never got those before. Now, lots of kids get them. All right. So I looked up type 2 diabetes and fatty liver disease. And of course, I know a lot about both of them, but I very specifically looked for origins and causation. And it turns out that in the old days, back in the 1970s, before this pandemic of chronic disease started, both those diseases were the diseases of alcohol. Type 2 diabetes and fatty liver disease were the diseases of alcohol. But kids don't drink alcohol. So I said, all right, is there something they're exposed to that's like alcohol? So I opened up my Leninger, biochemistry textbook from 1974, sitting at this table that I'm at right now. I said, what the hell is like alcohol? And there it was, and stared me right in the friggin' face, right off the page from 1974. And the answer was fructose. Fructose and alcohol are metabolized virtually identically. And it makes sense that would be the case, because after all, where do you get alcohol from? Fermentation of fructose. It's called wine.
Yeah.
We do it in Napa and Sonoma every day. Okay. The big difference between fructose and alcohol is that for alcohol, the yeast does the first step of metabolism called glycolysis. For fructose, we do our own first step of metabolism. But after that, what the mitochondria see are exactly the same as acetyl-CoA. It's just a question of which was the substrate. Was it the ethanol or was it the fructose? But ultimately, they end up with the same fate. So it's very clear, all of a sudden, right, looking at that right there, that this is the substrate that is driving both the type 2 diabetes and the fatty liver disease. Mm-hmm. So I put together a talk, and I went to North Carolina, and I said, this is what I think's going on, and here's why. Half-hour talk. And then there was the bathroom break. And, I got my applause, and then everyone left the room, and they didn't come back. I'm standing there at the podium talking with, this person, that person, and no one's coming back for the next session. And then I had to use the bathroom. So I went out, and I actually got tackled in the friggin' bathroom of the NIH by a bunch of crazed toxicologists screaming at me saying, oh my God, you're right. This makes perfect sense. This is the toxin. You have to tell everyone about this. And I guess I'm still doing it.
I guess you still are.
So if the toxicologist went berserk, it might be true. And then that was the second aha. And then the third aha was not even my aha. It was my colleague's aha, but I adopted it. So we got very interested in sugar here at UCSF after that. And we actually have a group of us we call the Sugar Hill Gang. They're actually referenced in the book here. But my colleagues, Kristen Carnes, Laura Schmidt, and Stan Glantz, started looking at the paper trail of the food industry back in the 1960s and found the actual paper trail that showed that the food industry paid off scientists to exonerate sugar and finger saturated fat as the bad guy. We actually found their documents that showed the money transfer and the communications, just like what the January 6th committee is doing now, follow the money. And we actually proved that the sugar industry put their thumb on the scale back in the 1960s to exonerate their product, because there had been data that had been coming out at that point showing that sugar was not good for you. In fact, that's what John Yudkin found. Remember, Pure, White, and Deadly. And he had found, shown that data. And so people were starting to cast a fisheye at sugar. And so they had to go into overdrive mode to PR this problem away. And so they approached the chairman of the Department of Nutrition at the Harvard School of Public Health, Fred Stair, and his associate, Marg Hegstead, who ended up becoming the head of the U.S. Department of Agriculture in 1970, to pay them off $6,500 back then, which would be about $50,000 today, to write 2 review articles to appear in the New England Journal of Medicine that basically said saturated fat's the bad guy and sugar is no problem whatsoever. So that's the third aha moment. It's all a scam. The whole thing's a put-up job. And that's why I wrote Metabolic.
You know what I'd love to see, and I'm not aware of any studies or research where they've done this. You might be. I hope you are. But what I'd love to see is You know, in some of the populations around the world where historically they would have 80% of their diet from carbohydrates, but whole food carbohydrates, let's say the Okinawans, maybe not the new generation, but a few decades ago, the generations who were eating whole foods and were having those purple sweet potatoes. I'd just love to know if they were wearing a CGM, what on earth was going on with their blood sugars, because it would be quite interesting in that very low stress environment where they're moving lots and they're getting good amounts of sleep and they've got strong community. When they're having these whole food sweet potatoes, you know, what is that doing? Is their sugar curve relatively flat? You know, I don't wear a CGM all the time. I probably wear one for 2 weeks, I would say every few months. Right. So I don't personally want to get overly reliant on it or too obsessed, but I use it maybe 2 or 3 times a year. I put it on for 2 weeks just to see where I'm at and give me an idea of the regular foods I'm consuming. What are they doing? And one of the things I discovered is that sweet potato wedges shoot my blood sugar up pretty high. You know,
so the thing we've learned, Rangan, and you know, Levels Health is to be credited with this. And you know, I'm full disclosure, I'm an advisor to Levels, and one of the reasons is because I recognize that this is an important component of metabolic health, is maintaining, you know, your glucose homeostasis in a good place, because that basically translates into functioning mitochondria, and that's what I'm really espousing here. But having said that, and you know, not that it's an advertisement for Levels, but the bottom line is everybody has their, shall we say, bad food, you know, their problem food, the food that they think is good for them, which turns out not to be so much. All right. Everyone's got one. And, you know, everyone says oatmeal's good. Yeah, but for oatmeal, you know, like 25% of the population spikes like crazy. Okay, even though it's supposed to be something that's supposed to give you, you know, a consistent and, you know, non-spiky glucose excursion. That turns out not to be true for a lot of people. Different people, different problems. And so the only way to answer these questions is for you to do it yourself.
Yeah, that's super interesting, Rob. What do you say to opponents of continuous glucose monitors who say that looking at these blood sugar excursions, and again, for someone who's never used one of these before, essentially you basically see in real time what your blood glucose is doing, and you can very quickly extrapolate, oh, when I eat this kind of food or this quantity of this type of food, this is what happens to my blood sugar. Now, it's not universally accepted that this is a good thing, right? Some opponents would say that getting obsessed with these blood sugar ups and downs is pathologizing a normal physiological response. What do you say to that, Rob?
So there is no question that we have this thing out there now called orthorexia. So orthorexia is basically a pathological hypervigilance about food, okay, and that anything can hurt you. And some people have actually, you know, accused me of contributing to this phenomenon and, you know, concept of orthorexia. You know, look, there's always going to be the pendulum swinging one way and the other. When we didn't care about what our food did, look what happened. If you care too much about what your food does, yeah, that's a problem too. Somehow we have to find the place in the middle. And there are probably some people that should not wear CGMs because they can't manage the influx of data that comes in. But what we really need is the ability to acquire the information, the ability to integrate the information so that it means something, because just because you gather data doesn't mean it actually is data you can use. You have to be able to integrate it. And then you have to be able to disseminate it to the patient in a meaningful way that they can understand. So 3 separate phenomena: acquisition, integration, dissemination. And you have to be able to do all 3 accurately and correctly, and for the right patient.
Yeah.
You know, the fact is, we've had this problem throughout all of medicine. Ultimately, it is something you need to discuss with your doctor, because your doctor knows you best. But the idea that you shouldn't use it because, some people might consider it a problem is, that's how you get into trouble, actually.
Yeah.
So, no, I'm not okay with that. Yes, I agree. We need to take this down to the per patient level.
Yeah.
This shouldn't be a blanket recommendation across all population.
And I think sort of opponents to CGMs also, I think sometimes they make quite a black and white extreme argument, which is, if you eat just bacon 3 times a day, 7 days a week, you'll have a completely perfect blood glucose stable response, right? But nobody's saying that only blood glucose matters.
No. And that's correct. So first of all, there are a whole bunch of carnivores out there. Okay. And, carnivores will have the most stable of blood glucoses. And the reason is because they're not running on glucose, they're running on ketones because they're carnivores. Right? The fact is that the glucose excursion does matter, and the reduction in the glucose excursion can provide metabolic safety to some extent.
Yeah.
Now, having said that, what if a patient with familial hypercholesterolemia decides to go carnivore? That's a really bad idea. Okay, that's a great way to end up with cardiovascular disease really quick. Again, it's which patient are you and what's going on with you, and you have to do this individually.
Yeah.
Now, one of the knocks against CGMs is, well, you don't have diabetes. Why do you need a CGM? It's actually because you don't have diabetes that you actually do need the CGM, all right? Because it will give you information to prevent diabetes, not just treat it. And that's what we've learned is, super important, especially when, 45% of America is now pre-diabetic because they're insulin resistant. So how do you fix that? Well, glucose is one channel.
It's one of them.
It's one way. It's only one. It's not all of them. Okay.
Yeah.
So ultimately, we're going to need more channels. And I agree with that. We need ketones, we need lactate, and ultimately the one we need the most is insulin.
Yeah.
We need an in real-time insulin monitor to basically tell us how high does your insulin go when you eat certain foods. Now, the problem with insulin is because it's a peptide and because it's extremely low concentration, it's much harder to measure in real time. But people are working on that. We'll probably have it in about 4 to 5 years. Does that mean we shouldn't be using glucose in the meantime? No, it just means that research will catch up to it and we'll have a better answer 5 years from now than we do today. But we still have an answer now.
Yeah. I mean, anything, generally speaking, that you can do to educate yourself about your own individual responses, I think by and large, for most people is a good thing, but it's a question of balance. I think our personality plays a role here as well. Some of us are more likely to become anxious and obsessed. Other people can look at the data, in a much more distant way without it affecting every single food decision they make throughout the day. But, one person's obsession is another person's care and attention, right? So it's very hard to say what is right for another person, I think.
Having personal medical technology available to individual patients is, of course, going to have benefits, and it's also going to have drawbacks. Okay, it's a tool. Okay, every tool has its good and bad side. Okay, nuclear power can be a tool, right? In terms of generation of electricity, or it can be a downside. It can be, nuclear bomb. Okay, a hammer can hammer a nail. It can also hammer a skull. So just because something's a tool doesn't make it good or bad.
Yeah, it's how you use
it. It depends on the user. It depends on the purpose.
Yeah.
This is a tool. So for the right patient, it can be a good tool. Now, there are a lot of doctors out there who don't know how to use it. They were never trained on it. They don't understand it. They never learned about this. And so they're going to be faced with somebody walking into their office, with all of this data saying, explain this to me. And they're not going to be able to. And they're going to be like, screw this. Right? We already see this. We have these people who are coming into cardiologist's office with Oura rings. Oh my God, I threw a VPC. What am I going to do now? Turns out VPCs are normal.
Can you just explain what a VPC is for the audience?
Ventricular premature contractions, where your heart goes boop, boop, like that. Yeah. Turns out, until we had Oura rings, we didn't know how common they were, but they're common. So yes, this stuff happens. So we have to ultimately determine, like what's normal, what isn't. And, that expecting physicians to be able to, sit down with all of these data and be able to interpret this for any given patient might be asking too much of them.
Yeah.
So the question is, how do you then democratize this? How do you ultimately allow patients to be in possession of their own information so that they can utilize it properly? Well, that's the hard part. We can absolutely get people to be in charge of their own information. The question is, how do we know that they will utilize it properly? And that's where guardrails are needed.
Yeah, for sure.
All right. Okay. The bottom line is we have needed guardrails in our society for all sorts of things. Let me give you an example of what happens when guardrails work and when guardrails don't. Okay. In the last 75 years, there have been 5 major scientific breakthroughs that have changed the world. 5. Here they are. Nuclear weapons. As soon as they were used, everyone went straight to the table because they saw the immense disaster that could be coming. And so they established guardrails. And those guardrails, for the most part, are still in place, aren't they? Number 2, recombinant DNA. Back in the 70s, 80s. Okay. Everybody said, oh my God, we're going to unleash, some virus. Maybe, maybe we've already seen it. I don't know. That's to be determined. But what did they do? They established guardrails. And now, all this work is done in P4 facilities, very specifically to keep it from getting out. Number 3, CRISPR. Okay. CRISPR developed, recently, and that Chinese doctor made 2 designer babies, and everybody rushed to the table and established guardrails for how to be able to utilize this, so that we don't actually, re-engineer the human race. Number 4, social media. How'd we do with that one? Not so hot. No guardrails. And look what happened. And now we got number 5, AI. I don't know what we're going to do about that. Bottom line is, every one of these has the potential for basically helping people because they are tools, or hurting people if they are, basically democratized into the wrong hands. We need guardrails for these things. Well, we need guardrails for CGMs too. We need guardrails for virtually everything we do in medicine. Okay, so I'm for patients owning their data. I am for patients understanding what's happening to them. I am for patients taking control of their own health within guidelines and within the guardrails that need to be set up for it. So that's how I feel.
We started off this conversation, Rob, talking about the different fat depots, right? The 3 places where we can store fat: subcutaneous, visceral, and liver. And what was so interesting about that is that we can tolerate much more fat accumulation subcutaneously. You said 22 pounds on average before it starts to cause a problem. Whereas visceral fats, we can only tolerate about 5 pounds or so before it starts causing real harm to us. Whereas with the liver, it's only 0.3 pounds. Now, just to make sure everyone's following along with this, the subcutaneous fat we were saying was from, consuming excess, and your body will store that excess in a relatively safe place unless it gets too much. You were saying stress is ultimately the key driver of visceral fat, which we know is really, really problematic. What is the key driver of liver fat? I think you mentioned it was sugar and alcohol, or I should say
sugar and alcohol.
Fructose.
Sugar and alcohol.
Well, is sugar as a term problematic? Because when we use the term sugar, we know that people will say sugar is essential for life, and they might be talking about glucose, or they might be saying blood sugar. And I sometimes say blood sugar when I mean blood glucose. Are we at a stage where we need to be a bit more precise? Because the term sugar can be so misleading, can't it?
Oh, I so agree. You have hit me right where I live. The fact is that there are corporate interests that ultimately misuse all sorts of verbiage for their own purposes. Example, weight. Okay, what kind of weight are we talking about? Body weight, fat weight. Fat. Are we talking dietary fat? Are we talking, liver fat? Are we talking visceral fat, etc.? Sugar, right, exactly. Are we talking dietary sugar? Are we talking blood sugar, which is really blood glucose? Okay. Ultimately, a sugar is not a sugar. A fat is not a fat. A pound is not a pound. A calorie is not a calorie. A fiber is not a fiber. A protein is not a protein. An amino acid is not an amino acid. Okay. And down the line, of course, we should be more exact. And I endeavor and strive to be more exact. Unfortunately, the population has not been educated into what these things are. So it tends to regress back to the mean. And of course, because corporations actually hide behind this, because they say, well, a sugar is a sugar, therefore I can put any amount of sugar I want in this thing. It is a problem. So yes, educating the public has been a major component of my work.
So when we then are talking about what drives liver fat specifically, you're saying alcohol. And when you say sugar, do you essentially mean excess fructose?
I mean fructose. I don't mean glucose. Yeah. I mean fructose. But because fructose is half of dietary sugar, and there is no fructose alone in nature, it always comes with fiber, except in honey. But how much honey are you eating? But pretty much everywhere else, it comes with fiber.
Let's just pause on honey for a minute, because many people will consume honey as a healthier option because it's natural compared to, let's say, table sugar or refined sugar. Right. Now, I'm putting this out there just to get your view on this. The Hadza tribe in Tanzania, hunter-gatherer tribe that has been, very, very well studied by lots of different groups, are well known to gorge on honey when it is available. If they're on a hunt and they come across honey, from what I understand, they will often gorge on that honey. Now, I'm also aware that these guys have great gut microbiomes. They're very, very physically active. They do not touch ultra-processed food. It's all food from nature, etc., etc. So they're consuming, potentially, on occasion, large volumes of honey. For the regular urban dweller who is listening to us chat now, should they learn anything from the Hadza about honey, or for us, is it completely different?
If you want to gorge on honey, have at it. All right? And the reason is because honey's so friggin' expensive that if you gorge on it, you're going to be broke. You're not going to be able to afford it. The big problem with honey is not honey. The big problem with honey is the fraud of honey, because almost all of the honey in the store is not honey. My colleague Mitchell Weinberg actually set up a check and balance system on honey to keep honey fraud off the market. Almost all of the honey that you buy in commercial grocery stores, unless you buy them in very artisan shops, is actually a conglomeration of glucose syrup and, fructose and, some artificial flavors. Honey fraud is the single biggest fraud item in food worldwide.
Wow.
There are other things too. There are wine fraud. There's fish fraud. There's Scotch fraud. That's a big one. But honey is one of the biggest. And so they've actually developed a method for determining whether or not the honey you're eating is actually honey.
First of all, I didn't know that. That's really, really interesting and slightly concerning. In our first conversation, you explained that table sugar is sucrose, which is made up of glucose and fructose. Okay.
Yep.
What is natural, real honey? Like, what is that made of? Assuming what we were buying, or let's say what the Hadza are gorging on in nature, right? What is that made up of?
It's made up of sucrose. It's made up of glucose and fructose. And it's got a couple of other bioactive compounds. Now, those bioactive compounds have never been shown to do anything. They may do something, but not usually in the amounts and concentrations that people consume them in. There are a lot of people who say, well, honey is good for you. Show me the data that shows that honey is good for you. There are a lot of people who say it. I'm still waiting to see the data.
Are you essentially saying that for someone who is probably not in the best metabolic health, which is most people, consuming honey from a metabolic health perspective is pretty much the same thing as consuming table sugar?
Yeah. The good thing about honey is because it's expensive and because it has its own unique flavor, people tend to use less of it. And anything that makes you use less of it, as far as I'm concerned, is good. But from the standpoint of gram for gram, ounce for ounce, calorie for calorie, it's basically no different from sucrose.
Okay, so let's go back to liver fat for a minute then. So liver fat, it doesn't take much liver fat accumulation, 0.3 pounds, as you mentioned, to start causing problems. Now, that doesn't sound like much at all. And you're saying that excess fructose and alcohol are the two main drivers of that.
One of the other, there are two other drivers of it as well. Trans fats did that like crazy.
Yeah.
But as we learned that, and in 2013, the FDA banned trans fats in foods. So that's good, except, by the way, there are still trans fats in foods because of the FDA rules here in the United States that say if you are below 0.5 grams of trans fat, you can say 0. You get to round down. So if you have 0.49, you get to say 0. Now, we have learned that 2 grams of trans fats are cardiovascularly toxic. If you consume 2 grams of trans fats per day, you're going to get heart disease. So if you consume 4 candy bars that say that they have no trans fats in them, there's a good chance that you will have gotten the equivalent of 2 grams. So just because it says none doesn't mean it's none. This is one of the other subterfuges of the food industry. So that's one thing. And then the fourth thing that causes this liver fat is branched chain amino acids. So leucine, isoleucine, valine. Now, these 3 branched chain amino acids are common. They are 20% of muscle. So if I took a muscle biopsy and I subjected it to amino acid analysis, okay, 20% of the amino acids in muscle are branched chain amino acids. And all 3 of those branched chain amino acids are essential amino acids. You have to consume them. You can't make them. So leucine, isoleucine, valine, you have to consume them. It's not like you can make your diet branched chain amino acid free. You need them. But if you consume excess branched chain amino acids and you're not laying down muscle, so you have no place to put the branched chain amino acids into, and you consume excess, Where's the excess go? So they go to the liver. The liver takes the amino group off. Now they're a branched chain organic acid. And now they go into the Krebs cycle, go into the tricarboxylic acid cycle in the mitochondria. You've now added extra substrate that the mitochondria can't process. It overloads it. And so you're going to throw off that citrate, and that citrate's going to end up undergoing de novo lipogenesis, and you're going to make liver fat out of the amino acids because you didn't need them. So branched chain amino acids, if you're a bodybuilder, are great. And so that's why bodybuilders, scoop protein powder, when they make their smoothie shakes. And, if you're a bodybuilder, that's okay. But if you're not a bodybuilder and you're taking excess branched chain amino acids, all you're doing is increasing your liver fat.
Yeah.
And that's what we're seeing. And so the question is, all right, where is the, Joe Schmo getting his branched chain amino acids from? And the answer is corn. Corn-fed beef, chicken, and fish, which here in the United States is virtually all of our protein supply.
So that's different from grass-fed.
Exactly. Grass-fed has less branched chain amino acids.
If you enjoyed that conversation, I think you're really going to enjoy this one about the things that you can do right now to heal your body and prevent disease.
How much vitamin D do you need to not get rickets? Probably 30 units. How much vitamin D do you need to optimize your immune system and prevent cancer and heart disease and all these other benefits? Probably 2,000 to 4,000.